Hello everyone. Today we're going to continue with the next three skills in rates and proportional relationships, starting with constant and proportionality from tables, then moving on to constant and proportionality from tables with equations, and then lastly we're going to talk about comparing constants of proportionality. So let's go back to constant of proportionality from tables. Now, in the last lesson we talked about the constant of proportionality, and really all it is just a unit rate, okay? And we also discussed the three different ways that we can tell if we have a proportional relationship. The first being that it begins at the origin on your graph. Secondly, that it forms a straight line or it's linear. And lastly, that your constant of proportionality, which is r equals y divided by x, is the same for all data points in your graph. So it's asking which table has a constant of proportionality between y and x of 2. So we're going to look at each particular graph. If I divide my y by x, which would be in the first row here of answer choice A, would be 5 over 2, does that give me a constant of proportionality of 2? No, it would equal 2.5. So right away I can tell that answer choice A is incorrect. Let's take a look at answer choice B. If I divide y by x, 6 divided by 3, that gives me 2. If I divide y by x here, that also gives me 2. And then lastly, for the last row, 36 divided by 18, that also gives me a constant of proportionality of 2. Now notice it does say choose one answer, so B would be the only correct choice. If we did the same thing down here, 24 divided by 6 is 4, so right away you can see that C is also incorrect. So where we say the constant of proportionality needs to be the same for all data points, well, 3, 6 would be a data point, 5, 10 would be a data point, let's put our commas in, and 18, 36 would be a data point. So in this case, we did get a constant of proportionality or a unit rate of 2 for all three of those data points. Let's try another one. Which table has a constant of proportionality between y and x of 0.6? Well, 0.6 is the same thing as 6/10, which if I simplify that, we're looking for a simplified fraction of 3/5. And as we remember, r is our constant of proportionality, and to find it, we do y over x. So that means 3 would be your y, and 5 would be your x. That's what we're looking for. So taking a look at the first one, if I do 7 divided by 4, that gives me a constant of proportionality of 1 3/4 or 1.75. So right away I can tell A is incorrect. Next, if we divide, and you can use a calculator for this one if you would like, if we divide y by x, that's going to be 2.4 divided by 4. Well, if we type that in our calculator, that's going to give us 0.6, which is what we're looking for. So far this one looks good, but remember it needs to be 0.6 for all data points. So we have to check it for all of them. 5.4 divided by 9 also gives me 0.6. 8.4 divided by 14 also gives me 0.6. So right away I can see that B is the correct answer, and again we're just looking for one correct answer here, but just looking at answer choice C, if I did y over x, that would be 2/3, which equals 0.6 repeating, which means it continues. So C would not be correct for this one. Okay, let's try one more of these. Which table has a constant of proportionality between y and x of 0.9? So again, we're doing the same type of thing. So if I divide 9 by 10, that's going to give me 0.9. Let's try 17 divided by 18. On my calculator, I get 0.94. So now hopefully we see, it's 9.4 repeating, that you do need to check each one, because our first one was correct, but notice our second one does not give us 0.9. So A is incorrect. Let's try the next one. 3.6 divided by 4 gives me 0.9. 5.4 divided by 6 also gives me 0.9. And then 10.8 divided by 12 also gives me 0.9. So again, B happens to be the correct answer choice here. If I do 3.3 divided by 3, that gives me 1.1. 9.9 divided by 9 is also 1.1. And 12.1 divided by 11 gives me 1.1, which we are looking for 0.9. Okay, moving along to the constant of proportionality from tables with equations. Well, this is where you're going to be using your constant of proportionality equation, okay? And we have our equation right here. It's y equals rx, where we know r represents our constant of proportionality. I'm just going to abbreviate that. And x and y are your x coordinate and your y coordinate from your table. That's your data point. So in this case, they're just asking us to find the constant of proportionality, and we know that to find our constant of proportionality, we're just dividing y over x. So taking a look at our table, we've got 35 divided by 7, which would give me a constant of proportionality of 5. 60 divided by 12 also gives me 5. And lastly, 100 divided by 20 gives me a constant of 5. This is a proportional relationship. It tells us it is, but we can also check it. Our constant of proportionality is the same for all data points, making it a constant of proportionality of 5. Okay, the quantities x and y are proportional. Find the constant of proportionality in the equation y equals rx. So again, we're simply just doing r equals y divided by x. So 30 divided by 3 gives us 10. 100 divided by 10 is 10. And lastly, 160 divided by 16 is also 10, making our constant of proportionality r equals 10. So if I were to write this in my equation, it would simply just be y equals 10x. Okay, again, we have another proportional relationship, and they're asking us to find the constant of proportionality. So just like we did in the others, we're just going to divide y by x. 36 divided by 12 is 3. 54 divided by 18 is also 3. And lastly, 75 divided by 25 is 3 as well. So that makes our constant of proportionality, or our unit rate, 3. If for some reason we wanted to write it in our equation, you would simply just plug 3 in where r is, and that would be your equation. Okay, the last one we're going to do today is comparing constant of proportionality. So in this case, they're going to give you a couple different they're going to give you a proportional relationship like they did here, and we're going to have to find 3 answers that have the same proportional relationship or the same constant. So it says, which relationships have the same constant of proportionality between y and x as the equation 3y equals 27x? Now, I will suggest that you always simplify your equation, which means to eliminate your coefficient in front of your y. In this case, that's a 3, and to get y by itself, we're simply just going to divide both sides by 3, leaving us with y equals 9x, which means our constant of proportionality is 9. So we want to find 3 answer choices that have the same exact constant of proportionality. So if you look at answer choice A, y equals 9x, well, that's the same thing we have right here once we simplified. So A is correct. 2y equals 18x. Well, if I get y by itself here, again, that leaves me with y equals 9x. So B is also correct. Now we're looking at one more. So let's take a look here. I can see my point is at 1, 9. And we know that to find our constant of proportionality, we're just dividing y by x. So if I divide 9 by 1, that gives me a constant of 9. So A, B, and C would be the correct answers here. Right away I can tell that my table is incorrect for D, because if I divide y by x down here at the bottom, skipping through the fractional ones, that gives me 1/9, not 9/1. And then here, yes, 18 divided by 2 is 9. However, 27 divided by 4 is not 9. So E would not work. Let's try another one. Evelyn, Neil, and Lilani swim laps at constant rates. Select the swimmer who swims the fastest. Well, Evelyn swims 4 laps in 216 seconds. Before we continue though, let's just backtrack real quick. It says they swim at constant rates, but remember, select the swimmer who swims the fastest, and remember the fastest swimmer swims laps in the shortest amount of time. So just keep that in mind. So it says Evelyn swims 4 laps in 216 seconds. So we want to know how many seconds per 1 lap. So that means we're going to put seconds on the top. Whoops, sorry, that should be a 6. Divided by the 4 laps, and that's going to give us a total time. Well, 216 divided by 4 gives us 54 seconds per 1 lap. Now the next one's a little bit trickier because they give you the equation where L represents laps and S represents total seconds. So we want to know how many seconds per 1 lap. So in order to do that, we have to first simplify our equation. And what we end up getting, 126 divided by 3 gives us 42 L equals S. So what that means is your constant of proportionality, or your unit rate, is 42, which means that Neil is swimming 42 seconds per 1 lap to equal your total seconds. So if he's doing 42 seconds per 1 lap. And the last one's a little bit easier because they tell you in 1 lap it took Lilani 32 seconds per lap. So we want to know who the fastest swimmer is, and just a reminder, your fastest swimmer is the person that swims in the least amount of time. So we've got 54, 42, and 32, so clearly Lilani is your fastest swimmer. Which relationships have the same constant of proportionality between y and x as the following table? Well, the table given, if I were to do y over x, because remember r equals y over x, that would give me 7 divided by 2, which equals 3.5. If I do 24.5 divided by 7, that also gives me 3.5. And 31.5 divided by 9 also gives me 3.5, which makes sense because they did say that they have the same constant. So we're looking for r equals 3.5, or if we wrote it as a fraction, 7/2. So let's take a look at answer choice A. If I were to get my y by itself, that would leave me with y equals 14/4, which if I divide both of those by 2, that leaves me with 7/2x. And there you see the constant we're looking for, 7/2. So A would be correct, but again, we have 3 answer choices. Here we have, remember, your constant of proportionality should follow the equation y equals rx, which means your constant of proportionality should be with your x variable. So if I get y by itself here, I'm going to end up with 1/3.5, which means B is incorrect, because 1 divided by 3.5 is 0.2857. It goes on. It's a repeating decimal, so that one is incorrect. The next one, the coordinate given is 1, 4. So if I did y over x, that would be 4 divided by 1, which is 4, so that one is incorrect. The next coordinate, we have 2, 7, which if I do y divided by x, that would be 7/2, which is correct. And then the last one we've got 4, comma 14. So again, y over x would be 14 over 4, which if I simplify that gives us 7 over 2. So E is also correct. So in this case, the correct answers were A, D, and E. Okay, that does it for those 3 skills. The correlating note-taking packet pages are pages 8 through 11. Have a great day, everyone.